looking at a type 2 equation, and so when you get equations, trigonometric equations of the form, so I'm just going to put over there type 2. When you get trigonometric equations of the form sine, right, and here's an example, 2x plus 10 degrees is equal to sine of 20 minus x degrees, right? Now, people, this is 20 degrees minus x. This is not a complicated one, because when you see this is an argument, this is a function, this is a function, and the same input is yielded there, and this is another input, and you have an equivalence relation. So we are told these things are equivalent. I can clearly now conclude that, that 20 minus x must be equal to this. So let's just look at what this is. This means I've got the function here, okay, or the ratio, the function or the trigonometric ratio, and then I've got an angle, which I call the given angle or an input, okay, and then I've got the same function, and then on this side I've got what we call the reference angle, right? Okay, because that's essentially what you're solving for. So using the QRS method, you can clearly see that we've got quadrants. This thing over here happens to be positive. So where is sine positive in terms of QRS? In the first quadrant and in the second quadrant, right? The reference angle, in fact, we can solve for that very easily because the reference angle is actually given, right? So with R, the reference angle happens to be 20 minus x. Okay, and then you need to go and solve. So when we solve, we simply use the reduction formulae approach, right? So when we solve, remember you solve for the first quadrant, and you're going to solve for the second quadrant. Solving for the first quadrant shows us the following. It makes the angle that was given, which is 2x plus 10, is equal to whatever the reduction formula is in that quadrant. And as you know, in the first quadrant we just have theta, right? So you're going to make this equal to 20 minus x plus n multiplied by 360 degrees. And 360 because we're working with the sine graph, which repeats itself every 360 degrees, such that n is an element of the integers, right? So now we can solve this very easily. This is going to give me 3x, because I've taken the x over, or I've added x to both sides. 10 and 10 cancels out, leaves me with 3x, that's 10, plus n times 360 degrees, and n is an element of the integers. I now divide both sides by 3, and that's going to give me a solution that follows x is equal to 10 over 3 degrees, which is 3,33 degrees recurring, right, plus n multiplied by 120 degrees, such that n is an element of the integers. So let's just do the second quadrant on this side. For the second quadrant, we do exactly the same thing, and we say, well, I've got 2x plus 10 degrees, which was the given angle, is equal to the reference angle, is used in the reduction formula format, which is 180 degrees minus theta, and in this case, that's going to be 20 minus x degrees, all right, plus n times 360, such that n is an element of z, right? 180, 170, 170 minus 20 is going to give you, that's going to be 150 degrees, right, plus x. So I've got plus x over here, and that cancels out with that, which leaves me with just 1x on this side. And that's going to give me plus n times 360 degrees, right? Okay, and then we state n is an element of z. Look, this point over here is very simple algebra. Just multiply the negative n, and that's what you get, right? And then take all the x's to one side, all the numbers to the other, and that's the solution that we find. So that's type 2 example. Please rewind, replay if I've done it a little bit too fast.